Okay, we're gonna get this cranked. My name is Pat Egan. Thank you for coming. I want to do this because I want to introduce two friends. This is Dr. Moerke and Kapuscinski. They've been doing some really great work and important work on the St. Mary's. And as the St. Mary's gets in better shape, these guys are teaching us more and more about the possibilities of the St. Mary's. And if you get a little time toward the end, you may want to talk to them about their freshwater research hopes. Well, and maybe we get a chance to talk a little bit more because it could be something very, very significant for the area and for really for the lakes. But in the meantime, we're going to tell you about all the brilliant things that they're doing. Kevin, I guess you first.
Thanks. Thanks for inviting us here. We'll start with a brief overview of the Aquatic Research Lab as it is today, and then highlight some of the successes, and then talk about what we hope for the future. I guess what we're planning for the future, because it will happen, it's not just a hope. So I'll start with our mission. Our mission is really to conduct research, to educate undergraduate students, and to engage the community, transfer that information we collect from research to the community. And we really achieve that mission through our students. So, of course, we work on training them. They work at the lab to raise fish. They work on research projects at the lab. They give tours of the lab. If you go get a tour of the lab later today, you may get a tour from a student. They also help us conduct research, so we hire them as paid employees. Sometimes they're volunteering to help conduct research. So the research may be funded through a grant that a faculty member has at our school or at another institution, and we may be collaborators on that, but oftentimes our students participate in that research, and then, as I mentioned, they'll be giving tours, but they'll also be at other events like Frog Fest. They'll man a table there where we'll have some information on invertebrates and Atlantic salmon and other fishes in the Great Lakes. So the history of the ARL, it was established in 1977, a little before my time here at Lake State. There was then the president of LSSU approached the university. He was as I understand it, an avid outdoorsman, but he's looking at not just increasing fishing opportunities, but preserving and protecting water quality, improving the ecosystem, which then could bring more people to Sault Ste. Marie and potentially increase demand for electricity and other things. We're really interested in improving the ecosystem. And then after several years, the Michigan DNR became a partner. So in the early days, the lab was involved in monitoring water quality, rearing some fishes like whitefish. I think they looked at brook trout and others. And then they started to work on Atlantic salmon and the Michigan DNR partner. So you're looking at 40 years of collaboration. And it really is this model of a private-public partnership. So Lake State, the DNR, now it's Global Electric SSM, but those individual entities could accomplish some things on their own. But working together, really able to accomplish much more. So there's really a synergistic effect there by working together. One of the outcomes or points of pride for the lab is this Atlantic salmon fishery that's being created. So it's estimated to contribute about $9 million annually to the Michigan economy, support quite a few jobs. The obvious ones are the fishing guides, but you also have to think about the hotels, the restaurants, etc., the service industries that are catering to those anglers that come here from all around the world to participate and make use of that fishery. We've been stocking Atlantics for about 30 years. One of the main differences between this species and the Pacific salmons is that the Pacific salmons, when they spawn, they die. Right? So usually you have that one chance to catch them as adults when they're returning into those tributaries. These Atlantics have the ability to survive spawning and reproduce more than once. So most of our fish come back at age 2, and we see them all the way up to age 5. So you may have that one fish may get caught multiple times in its life. The other interesting thing about this fishery or these fish is that they've been recaptured in all of the Great Lakes. So that each red star is a location where they've been recaptured. So some of those locations we have tens or more recaptures. It's not individual fish, but they've been recaptured all around the Great Lakes. Even in Lake Ontario, below Niagara Falls. So that student training I wanted to mention, we prepare our students for jobs mainly with natural resources agencies. Those could be state or federal. We have a number of students that work for tribal agencies and work for private fish hatcheries, and then NGOs like something like a Nature Conservancy type of organization. We're really well known for placing graduates in the DNR hatchery system. So about 3/4 of the hatchery staff are our alums. About 40% of fisheries division staff are our alums. Think about how small we are. We're about 2,000 students, whole university, versus some of the larger ones like Michigan State. You know, it's really a testament to the training that they get. One of the major things they get to do is work for Roger at the Aquatic Research Lab. So again, if you tour that lab, you'll get an idea of what they do on a day-to-day basis there. And all of our students have to complete a senior thesis project. This is another thing that sets them apart from other graduates. Each of our majors in biology has to do undergraduate research. And that is training they receive, but it also contributes, some of them contribute to that research mission, because some of these research projects have been published in peer-reviewed scientific journals. So the kind of journals that we as faculty are expected to publish in. On occasion, we have students publishing in those journals. So contributing to that information base that's used to manage our resources. And of course, the students do participate in outreach. The number we have here is that we say we have over 3,500 visitors a year. That's conservative. This year, I think we had over 4,500. Because of primarily the engineering days event at open house at the hydro facility. We had over 4,000 visitors on that day alone. But again, they're communicating with the public, but they're also engaged in K through 12 education events. So we may bring fish in and do fish dissections with some of the local schools, things of that nature. So to highlight some of the research, we brought in over $12 million in grants to the region. We typically employ at least 10 positions each year on those grants. So most of those are students, but some are recent graduates. And this research doesn't just address issues on the same areas, but it has a broader influence, as you'll see in some of the projects that we're going to highlight. All right, so the first one we're going to highlight is the coastal wetlands project.
Thanks. So if you go down, or if you've been down to the Aquatic Research Lab, if you go down, you'll see that the walls of our facility are a hatchery. So a lot of times, in fact, I was talking to Bernie Arvik just earlier today, and he mentioned something about the fish lab. So locals know our Aquatic Research Lab as the fish lab because that's where we rear the Atlantic salmon. And so the tours, that's what's most visible. But those walls really are not our boundaries, particularly for research. It's just our house where our equipment is stored. And so our influence goes much beyond that. So we've been working in a wide variety of areas throughout the Upper Great Lakes region. We're going to highlight a few of those, and I think we have some crazy animations going on. A few of those today. One of them that we're going to talk about is the importance of and health of Great Lakes coastal wetlands, primarily in the St. Mary's, but actually throughout the Great Lakes. We'll talk about our role in that. We've been doing a lot of work on imperiled species in the river. We've done tremendous work and published a lot on lake sturgeon. We won't talk much about that, but certainly we'd be happy to answer questions. We play a role in managing aquatic invasive species, and that's in early detection and monitoring efforts, along with some management and eradication efforts. And then after I talk about wetlands, Kevin's going to talk about the restoration of the Little Rapids, which is probably one of the most visible projects that we played a role in recent years. So coastal wetlands, we've kind of paid a lot of attention to in this region because it was about a decade ago that the Nature Conservancy came out with a report saying that the St. Mary's River was one of the most biologically diverse regions in the Great Lakes. And that reason for that biological diversity is because of our abundance of coastal wetlands. And these coastal wetlands range in types from kind of these these lake-like wetlands to these wetlands that have kind of a barrier protection that erodes with time and with water levels and opens up and reconnects and then closes off again. And then we have those that are just kind of these riverine wetlands along the shore. But we have over about 2,000 distinct wetlands throughout the Great Lakes, and something about 15 to 20% of those are estimated to be just along our connecting channel in the river. So, kind of a greater abundance in this little region. We've known for a long time that they're critical habitat, that a number of species require, a number of species of fish require, apparently fish is missing. Over 80 species of fish require coastal wetlands for some part of their life cycle. That might be that they require it for spawning or for nursery areas to raise their young. We know they're important for invertebrates that are a food source and kind of the base of that for a lot of those fish. And then we also know that they're important for bird species, some that are resident and some that are migratory. So they play these kind of distinct roles, and that's often the reason why they're getting a lot more attention, is trying to protect the organisms that they support. The problem is that we have a history of managing our landscapes that ultimately is in contrast to protecting and conserving wetlands. And so the statistics across the U.S. are pretty horrifying. I mean, there are states like Indiana and Illinois that have lost 90% of their wetlands, and most of those are inland. But we aren't really immune to that on the coast. In fact, coastal wetlands, Michigan, for example, has lost about 50% of its inland wetlands, but we've lost about 70% of coastal wetlands along the Great Lakes. And a lot of that is due to a number of threats. Some of those that are obvious, like shoreline grooming. So we've had legislation in recent years that allows a more extreme shoreline grooming and development without regulation and protection of wetlands. People want these nice sandy beaches, and they don't want to have to wade through, aquatic vegetation in order to use that waterfront. And so shoreline grooming is often implemented to do that. But that's at a result of, or a cost of those native wetlands. Now, we also see that there are concerns with invasive species. In our region and throughout the Great Lakes, there are a few wetlands now that don't have invasive vegetation, and we're seeing other invasive invertebrates and fish that are impacting them as well. And then, of course, climate change, and particularly when we look at changes in water levels, are affecting the development of those wetlands too. So about maybe 15 years ago, there was a group that had identified that there were some huge gaps in our understanding of how important these Great Lakes wetlands were, and really what the status of those wetlands were. We didn't even know where kind of pristine wetlands were and where those most degraded wetlands were. So if we were looking to try to conserve, we couldn't even identify the sites that we needed to make sure to protect that were high quality, and we couldn't figure out the sites that we need to invest the money in order to restore them. We also didn't really know how they varied in these ecosystem services. So some of them are really important as nursery areas for certain fish, some are really important for filtering water quality. We didn't know which ones were more effective at that than other types. And then we didn't know what the target was when we were trying to restore. Like what is a successful restoration of a wetland? And so all of this led to a couple, a workshop that brought a number of scientists together in wetland science. And they essentially developed what's called the Great Lakes Wetland Consortium, which is a group of a number of scientists that have been working to develop a monitoring program that can be implemented across the entire Great Lakes, and that can be used to assess the status and health of all the wetlands in the Great Lakes. So this was novel. Up until about 8 years ago, this had never been done. We have a lot of people doing work on coastal wetlands, but we were all doing it in different ways, and we were all doing it at different time periods, and so there was no way to really compare across the Great Lakes to get an understanding of whether or not they were still healthy or how they were changing. And so our goal was really to be able to assess 100% of all the Great Lakes wetlands within a period of about 5 years. And so we have been working on Lake State as part of one of many collaborators on this team that is Great Lakes wide. And I always point out that we are the only undergraduate team that's part of it. All the other ones are run by graduate students. We're kind of proud of that. And we do just as good of a job. And this gives you an idea. We use a GIS database that essentially delineates or outlines all the wetlands using aerial photos, and then we go and kind of ground truth those. And we've essentially categorized, based on a number of criteria, that there are about 1,000 sampleable wetlands that fall within this criteria. And so the goal was over that 5-year period to make sure that we sampled all 1,000 of those wetlands. And then some of those we would sample again year after year to get some assessment of trends. So this just gives you an idea of many of the sites in the St. Mary's River. This is just a sample of our last couple of years. So my team for Lake State is responsible for eastern Lake Superior and northern Lake Huron, including the St. Mary's. And so we are sampling sites every year, kind of depends on what our site selection system gives us, that's throughout the St. Mary's to get a better understanding of the health of those wetlands. And so the idea is that we're trying to do what's called SASM's trends. So we're trying to say, okay, what's the health? What are good sites and what are bad sites? So we're looking at that across the entire Great Lakes. So these are just kind of examples. So wherever there are coastal wetlands, we're trying to get a good spatial summary of where those are and what their health is. Then we're looking at trends. And this is the idea that we want to look at how does that vary over time. So if we keep going back to a handful of these sites every year, we can start to ask questions like, how does changes in water levels, which we've seen fluctuate tremendously in recent years, how is that affecting the health of these wetlands or the communities that inhabit those wetlands? And so the idea is that the survey is meant to be able to assess both of those things. We're collecting a lot of data, mainly water chemistry data, aquatic vegetation data, macroinvertebrates, which are dominated by aquatic insects, and then fisheries data. And so if you've seen our boat that says Lake State out on the river during the summer, that's often what that crew is doing, is out sampling as part of this consortium. We use an approach called bioassessment, which bioassessment is just using biological communities to help us understand what's healthy and what's degraded. And so the idea is that when we look at a community of organisms, so in this case it's aquatic invertebrates, if this is our sample, the individuals or the species that are present or those that are absent can tell us something about how degraded that water body is, or how kind of pristine or healthy that water body is. So in this case, for example, we could have two samples, one that might look like this and one that might look like this, which to maybe just the general observer looks the same, like looks like a bunch of dots. But what you actually see is that the taxa, or the species that are present, are really different. And these are indicators of good water, of low pollution, low sedimentation impacts, lower nutrient impacts. Whereas these individuals are indicators of degraded water systems. So high pollution, it might be organic pollution or sedimentation. And so we're doing this, using this approach with all organisms, with the aquatic vegetation, with the aquatic macroinvertebrates, and with the fish, to essentially develop these models that tell us what a healthy wetland looks like and what a degraded wetland looks like. And so we have done this. I'm just going to kind of walk you through really briefly kind of the idea behind it. Is that we're developing indices for the entire Great Lakes that are based on a number of measurements that reflect the community. So in this case, for example, for fish, we have found that a number of non-native species increases with increasing nutrient concentration. So as we see a wetland's water quality is becoming degraded, we see more invasive or non-native species. In contrast, when we have better water quality and better vegetation, native vegetation stands, we see that the percent of nest spawners increases. So fish that are actually creating a little nest and guarding it, those are representative of healthier sites. So we basically develop these relationships using hundreds of sites across the Great Lakes, and we can determine which measurements of the fish community are related to high quality and which are related to low quality. And then we summarize those and we compare them to a reference condition, which is based on systems that have very few land use impacts or alterations to the shoreline. And then ultimately, these are all added together with some additional ones, and they come up with a really simple metric of ecosystem health that is easily interpretable by the community, by the public. So if you know that it's a 0 out of 100, and you see the wetland that's in your backyard is a 10, and it could be 100, that tells you that that system's pretty unhealthy. Now, it won't tell you exactly what's wrong with it, but we can break down these metrics, and that can sometimes lead us to, is it sediment that is the issue? Is it nutrients? Is it invasive species that are the cause for that decline? And so the idea is to develop these metrics and develop these indices for a number of different biological communities, and then to apply that across the Great Lakes. to be able to compare how our wetlands in the St. Mary's look compared to other places. So we've been doing that, and this is just a handful of our data. One thing you'll notice is here's the St. Mary's. One, we've got a lot of dots on top of each other. As I mentioned, we have a lot more of those wetland sites within our backyards. We're pretty lucky. And not too surprisingly, we have more of these dark green and light green dots, which are considered the higher quality wetlands than what you might see in Lake Erie or Lake Ontario. So they tend to be really kind of degraded wetland sites in those systems. Now we have some that are yellow. We even have one that's an orange that's kind of very unique there. So the St. Mary's River isn't necessarily immune to impacts. It's just relative to some of our other systems, we're doing quite well. So this is what vegetation shows us. The other thing we can look at is some other, just those individual metrics. So this is just a graph that's showing you the number of wetlands that have how many invasive species of vegetation they have. So you can see that there are about 30 out of our 300 in this sampling group that have zero non-native or zero invasive species. So that tells us that only 10% of our coastal wetlands are free of invasive plants. So you can see that kind of how invasive plants have become ubiquitous throughout the Great Lakes region in these wetlands. We've done a similar thing with fish. Fish will often respond to different types of stressors that are affecting them because they can move. And so they don't necessarily show us the same results in terms of healthy or degraded. So you can see now we have more yellow and we even have some red sites. Some of those are down in Raber Bay, which experiences a lot of vegetation kind of mowing or pass-through areas for boat traffic, and also it has a lot of non-native vegetation present within that site. And it seems to be affecting the fish community. But we have found that across our system, we have nearly 100 species that are using those coastal wetlands. And so it's clear that these are really integral components for sustaining fisheries throughout the Great Lakes. And then the macroinvertebrate communities are reflecting more local conditions. They respond to the vegetation that's right in their immediate vicinity. And they're all suggesting that the macroinvertebrate communities are less impacted in the St. Mary's River compared to some of the other regions. These data are much more intensive to actually calculate or just to identify. So we don't have as many sites completed at this point, but the idea is to populate that. So the idea then is that this project is in year 6 of 10, and by that time we will have been able to, we're already working on it, essentially identify the areas that have these kind of more pristine or healthy wetlands and those that are more impaired. We'll be able to see how that's changing over time. Are we finding that our wetlands are actually improving with a lot of the input of Great Lakes restoration funds? And then we can also contribute to some early detection and management of non-native species. One example, or two examples of that, are European frogbit, which was found in Raber Bay and Manasquan Bay a number of years ago. And so some of those sites, the first detections were through the Wetland Consortium when we were out in those areas. The other one is the faucet snail, which is concerned because it is host to a parasite, a fluke, that can actually kill waterfowl that ingest it. And so this is, Bithynia has been found in our backyard, but it's found in western Lake Superior and northern Lake Huron. It's the first evidence of that coming up. And that was identified early by this Wetlands Consortium program. The final outcome that is probably, in terms of the federal government, is most interest is this idea that we can help prioritize where we restore and where we protect. So there's a lot of money coming in, about $300 million for the last few years from the Great Lakes Restoration Initiative. And that's meant to be able to identify habitats that are high quality and conserve those, buy that land up, put them in protected conservation easements, or prioritize those that are degraded to be restored. And so there are targets. So the EPA has listed targets that involve action items to protect a certain amount of coastal wetlands, and that they want to restore a certain acreage of coastal wetlands each year. So our data are directly feeding into the agencies to help them identify which sites those are as well. And I think the best part about it, and we've gotten a lot of interest from like local conservation groups, is that all of our data are available online. So if you live on the river, or you fish the river, or anywhere in the Great Lakes, you can go to the Great Lakes Wetlands.org portal, and it's hosted through Central Michigan University's Great Lakes Institute. But the idea is that you can go onto this mapping tool and zoom in to where you're interested, and then you can get, depending on your level of access, everybody can at least pull up the healthy index. Is it healthy or is it degraded? And then you can pull up a species list. So you can see what species have been found in that area. And our group isn't doing it, but part of the consortium, they're also doing bird surveys. So that includes bird survey data as well. And so it's available to essentially give you some idea of how important those areas are and how healthy or degraded those areas are in maybe a region of interest. So that is all I have on the coastal wetlands. Any questions about that before we move on to the next project?
How do you establish your reference?
So it's a bit of a kind of a modeling technique that we essentially use land use indicators. So we're looking at what land use types exist in the watershed, and shoreline indicators for shoreline modification. And then we layer that with different point source pollutants. So the land use is supposed to be non-point source. And then those that have lower evidence of land use alteration, shoreline alteration, and point sources are considered our reference conditions. So and that's done by lake, because within a lake there are just such a range of variation that wouldn't be observed if we kind of messed it all together across the Great Lakes.
So how do you establish degradation from just, how do you establish that on a percentage or numerical basis?
So it's not a percentage, it's essentially almost a ranking. So what we do, if you imagine if we have 100 sites, and we know, let's say percent nest spawners, and we can see the range of percent nest spawners at those sites. We then relate that to whatever that measure of degradation is. So land use would be a simple example of that. So as land use increases, we would expect to see percent nest spawners decrease.
Okay.
So it's those parameters that have a strong relationship with the stressor.
In all your studies, have you seen about the spread of Freshwater?
Yeah, so in the St. Mary's we haven't seen it as much, but Lake Huron and Lake Michigan, it is the big topic, is Phragmites and Phragmites control. And like one of our groups is in Saginaw, and many of their sites have been entirely taken over by Phragmites. The question, it was worse when our water levels were lower, because Phragmites could come in and establish in a lot of those areas. So we actually just had an email conversation last week about how is it this year, given everything is so high. And so we're all submitting data for our October 15th report. So I haven't heard that, because we don't see it as much of an issue up in our sites, but definitely those areas.
On the Canadian side, it's definitely cranking down.
Yeah, and we don't, so I didn't mention this, we handle the St. Mary's, but we handle all the US side, and the Canadian side is handled by the University of Windsor. Jansen Borowski.
So what does that do to biodiversity and water?
Yeah, so we see that there's definitely a relationship. The Phragmites stems are so thick that essentially we see very low oxygen in those areas, and we find very few fish, even forage fish. So the number of species is low, and the number of individuals is low. Yeah, not good. It is. It is. I mean, but even, and I don't know, maybe Eric could talk about this because they do more work in Manasquan. But even in Manasquan, I mean, the cattails, the changes that I've seen in narrow-leaf cattail coming in are really dominant as well. And so we haven't seen that affect the fishery yet, but I would be surprised if it didn't, because it's definitely more dense too. It's pretty,
Agreed.
It's pretty dramatic, isn't it?
Yeah, it's, I think something really interesting is I think people typically drive by cattails and don't think anything of it.
Yeah.
Most of the time, if you look over a marsh and you see nothing but cattails, it's not a good.
Yeah, exactly. I guess it's more the idea that just being monodominant is the problem. Okay, well, I'm going to turn it over to Kevin, and he's going to talk about the rapids restoration.
Thank you. Okay, so I want to clarify before I start. This is a great project, and it's going to sound like bragging. Okay? But of all the people that are involved in this, I am the least involved. Okay, so I'm not bragging about anything I have done. This is just an incredible project. Most of you that, if you're from around here or you've lived here for a amount of time, you know that the historical rapids are either almost entirely altered or have been destroyed. So there's, of course, the main rapids, and then the little rapids, which we'll be talking about today, and then I guess there were rapids down where the rock cut is now, but you know, that's just a chute. If you've ever been down there, it's channelized. About 90% of the historical volume has been lost through main rapids, and it currently covers less than 50% of the historical area. So there's a substantial loss of rapids habitat in the same area. And this picture shows what was there historically, and in the Little Rapids being, if you're at Rotary Park looking across where the ferry goes across, this would be behind where the ferry essentially docks on Sugar Island, but even that channel there is artificial. Right? So that ferry brings people across the island, and then of course they need to drive somewhere. So this causeway was put in. And this picture, I guess, is from 1939. So even then there was this causeway. There were 3 small bridges there that allowed some flow to go through. And at some point those were replaced with culverts. I don't know. Do you know? I don't know the
I
year.
think they think it's somewhere around the 50s.
So again, 60 some years ago, there were culverts placed in which further restricted that flow. So the goals of this project were to reconnect the flow. Obviously, that's the first goal, to get the flow back, and then provide and restore that high velocity habitat for lithophilic fishes, species that use clean bottom substrates for reproduction. So they'll deposit their eggs in gravel or cobble for reproduction. And they can't do that when there's sedimentation that fills in the gravel and cobble. Those fishes are typically don't have reproductive success after that occurs. So we want to restore that habitat. We, again, it wasn't me. I think this project's was ongoing for like 20 years.
The idea was.
The idea was for about 20 years in the making. So this was really a model for persistence, right? So they did some modeling of the flows, and this here, so this is the channel that was cut for navigation. This here is the former Little Rapids, the red showing little or no flow, and what we want to see after the project is completed is some flow restored, so these yellow, greens, and blues. And not just that there's flow there, but some diversity of flow, diversity of habitat, like what would have been there historically. So there are a few different options being considered. You can build a 600-foot span bridge, like this is an artist rendering here, but a single large span bridge, or you can build 2 smaller span bridges. And so they went through those discussions and they settled on a single 600-foot span bridge to replace that section of the causeway where those culverts were. And this was funded by NOAA, and construction occurred last fall, but what you'll see is that there's a large number of partners that were part of this project. So that was federal dollars that were passed through to some local agencies, and then Lake State is involved in the monitoring. But this was all initiated by some local folks, the Sportsman's Club and others. Is there anything else we should mention specifically?
Department of Transportation, the county Department of Transportation.
Yeah, the county, the road authority, they actually did manage the construction project. So what is the restoration supposed to achieve other than flow? We want to provide spawning habitat for native fishes, things like lake sturgeon, whitefish, and others. It wouldn't be at all surprising to see walleye spawning there, and then also provide habitat for native invertebrates. And then we anticipate it will benefit some of the sport fishes that may not be native, like the salmon. So there's been a lot of money put in restoration in the last 10 years. And it's really important to evaluate those actions to know if you really achieved your goal, if you really achieved restoration. So how this is being evaluated, first of all, of course, is measuring velocity. Is that flow restored? Right? And then look at the substrate. That flow restoration should provide a self-cleaning action where that substrate will remain clean over time, not fill in. And then when you have substrate, you should see the fish come and use it, right? They should be using that substrate for reproduction. They may use it for feeding at different times of the year. They may be feeding on these healthy invertebrate communities. So when those invertebrates are hatching off and moving around, the fish may capitalize on those resources. Other measures were, again, we wanted to improve the sport fishery, but then also engage the community and let them know this is there, let them know about the success of this project. It's a fairly substantial one. I think the final price tag was around $9 million. It actually came in under budget, which is something to celebrate, right? It came in under budget, and we want people to know that the money was spent wisely. And to know that it's an opportunity. There's actually part of the span bridge that's there now. There's a section, I guess you could say there's a divider between the road and the section where you can walk on foot, so you can fish off of that bridge now, where before you may not have had the opportunity. So there's opportunity to fish there, and the word is out, there are some fish coming in there. So before I get to what we're seeing now, I want to talk about some of the measurements they took beforehand. Again, to evaluate, you need to know what was there before you restored habitat to know, to compare it to what happened afterwards to know if you're successful. So this just shows the production of salmonids in the main rapids versus the little rapids. You can see that the colors of the lines are similar. Chinook salmon, pinks, pinooks, the hybrids between the two, and then steelhead. So you see similar species reproducing in those habitats, but the magnitude is much different. There's 6 times more pinooks coming off the main rapids than a little rapid. So a big difference there in the total production. If we look at adult fishes upstream and downstream of that causeway, we see some similarities in that there's a large proportion of the fish community is the centrarchids, the sunfishes. So that in this case is primarily rock bass. So they were the dominant centrarchid and one of the dominant fishes downstream of the causeway. The other fish that we're seeing in high numbers were primarily shiners and a minnow species, the blunt-nosed minnow. And we anticipate that you would still see high numbers of some of the minnows and shiners, because some of those are lithophilic spawners, but others aren't. So they all have different reproductive strategies. But what we anticipate we'll see is higher numbers of other species, other natives, like walleye, maybe like sturgeon, someday. There were several challenges to this project. Of course, it was expensive. And anytime you are proposing a large change like this, there may be some blowback from the public. Some people may not support the idea. So that was a long process getting people to support the project in general. And then another thing to consider from a biological or ecosystem perspective is anytime you alter the landscape, even if for restoration, there are invasive species that can capitalize on that. So you may see sea lamprey spawning in this area. And so we have to think about that. There are some trade-offs there. And so that would have to be monitored and potentially treated to kill sea lampreys in the future. So we don't have much for hard data to report right now. Monitoring is still going on. I think maybe they just stopped.
They just finished on Friday.
They just finished on Friday, netting for fish. So we know that the flow has been restored. Again, if you're not a regular traveler to Sugar Island, you can go out there. You can take your car on the ferry, or you can go by foot, and it's like $1 or something. So it's worth a check. You can go over there and check out this bridge. The picture doesn't really do it justice because you can see, when you're on the bridge, you can see the flowing water moving over these substrates that are clean and will continue to clean out as the flow is maintained. And that picture right there, this is one of the nets. This is a net that we use to capture drifting larval fishes or even drifting invertebrates. But that monitoring just wrapped up, so we don't have the hard results on that, but we have seen and heard reports of increased recreational use. There's people fishing there, there's some boats back there fishing right now. So it's really a great project. I really encourage you to go over and take a look at it. So now we're going to pass it back to Ashley to talk about the future.
So one of the things I think if you go down to the lab and that I always feel is when you go down to the lab, in fact I heard somebody describe it yesterday, it was one of our board members for Lake State, mentioned that when he walked into the lab it felt like a World War II bunker. And it's in an operating hydro plant, and so it is dirty, it has lots of spider webs, it has uninvited visitors all the time that sometimes eat just the heads off of our fish and leave them laying on the ground.
Those are the non-human visitors.
Those are generally the non-human visitors. And so just the facility has some limitations. Some of them are quite basic. Because it is in an operating hydro plant, and because we don't have any set area for visitors, we have issues with biosecurity in the sense that we get a school group in and they're all excited to see the Atlantic salmon, and it just takes one little kid to stick their hand that had some bacteria on it into that water system, and then that could potentially kill off those fish. So we don't have many regulations for biosecurity. We also don't have any laboratory space. I say modern, we technically have laboratory space, but we don't have, the infrastructure is lacking for city water and sewage. So that means that we're just getting river water, and all of our water is disposed of directly into the river, which means that we can't really do any type of water chemistry analyses, or we can process very little samples there just because we don't want to eliminate that waste into that system. And Roger, our lab manager, will tell you that his concern is less about the labs and more the fact that he doesn't have a bathroom. So he has to hike, a good, almost about 1/8 of a mile just to get to the restroom. So we plan ahead when we go down there. And we don't have any dedicated educational space. Kevin mentioned that we get thousands of visitors through the facility, and that to me always amazes me as well, just because it's the excitement about seeing the fish, but our possibilities to really make that into something more are endless. I talk a lot about kind of on my soapbox that when I came up here, I'm a freshwater biologist, that when I came up here I was stunned that there wasn't any place in kind of this eastern Upper Peninsula, northern Lower Peninsula to go to learn about the Great Lakes. We are nestled among 3 Great Lakes, and yet there's no facility or center that educates anybody of all ages on the Great Lakes and what we're doing and what the issues are and what the threats are and why we need to conserve it. And I feel like our facility could do that. And so we have been working for a long time, and I see Ed has probably heard this pitch at different phases, on creating what we're calling the Center for Freshwater Research and Education, or for short, we call it CFRE. And the idea is that we are going to create a modern space that has a Great Lakes Visitor Center and has an education center that would support K-12 education in the Upper Great Lakes region, as well as our undergraduate training needs.
And the Canadians again.
We're not there yet. Well, we're hoping that it's going to be collaborative and it's going to be cross-border. And so when we think about the center, like our vision of a true center is that we bring the experts that are working in this region all to one place. What the Canadians do much better in this area is that all of their biologists are located on the St. Mary's River. They're all out of Suaterra. We don't have a single fisheries or freshwater biologist for the government that's located in the Sioux. So the ones that are managing it are out of Gaylord or out of Newberry, and their districting is based on different issues. But it's been something we've been harping on for a long time, because you can't, if you're not connected, if it's not in your backyard, this amazing resource is really going to kind of deteriorate. So this has been a long process, as I mentioned. Ed has been familiar with this, but in 2007, so a decade ago, we were donated a building on the west end of the hydro plant, and we've been moving forward on renovating that building. There's all kinds of things that happened. We got money. We started to, you see these conceptual designs. We made these beautiful conceptual designs. Well, we got capital outlay money. in 2016, so we were just approved last year for nearly $9 million from the state. So the project is a $12 million project. Well, recently we found out that this building is no longer a possibility. There are some structural issues that just make it really costly. And so this is, I have to say though, that over those 10 years, there were a lot of ups and downs, and that's just one more of them. But as a result, what happened is that we got the state to approve, to allow us to use the money, which was dedicated to renovation of a historic building, for new construction. So we actually see this as a much better opportunity. We're not confined to the walls. Although it's a beautiful historic building, we're not confined to those walls. And if any of you are familiar with where we're currently located, on the east end of the hydro plant, there's Alford Park there, which is a very popular area for fishing. It's one of the only kind of shoreline access spots for fishing. Last year was closed down because they had shoreline instability, and so the city couldn't maintain that. So we've been in conversations with the city, and the idea is that we are going to build new construction in Alford Park. And so we're working on getting that land in exchange to make sure that there's community access to fishing and to just boat watching in that area, as well as to mooring boats. But now we're not starting from scratch, but we have an opportunity to make this bigger than we thought we could before. And so in the next few weeks, we're holding 2 visioning sessions. And those we'll be sending out invitations in the next week to people who are working in the region on community engagement and education. So that's engaging people about Great Lakes resources of all ages. We want to get ideas about what are the limitations in the region, what are our needs, how can this facility potentially help satisfy some of those, how can we be a solution to improving education issues in this region. And then the one on the 12th will be on research and management. So we're inviting many of our scientific colleagues that have been working on Great Lakes research issues and management issues to come and talk about how can our facility be a resource. We're an undergraduate institution, so we teach most of the time, and so we can't keep this facility going just on our own. It has to be collaborative, and that's what a true center is anyway. And so we're looking for tribal biologists and state biologists and federal biologists to try to contribute to see how can we as a facility or as expertise or as resources provide what they need in order to kind of address that mission of conducting and conserving or conducting research and conserving Great Lakes resources. So if you are interested, we have our emails up here. You can email us or just talk to us afterwards, and we'll put you on that invite list to make sure you come. If there are other people that we should be inviting that you know of, please let us know. And then if you haven't been down there or just would like to go again, our group is doing tours and some hands-on activities this afternoon. As Kevin mentioned, some of our students will be there, and Roger will be there, which is always fun. Or you can visit our fish cam, which is live now after much work. We got a new HD camera, and we still don't have the connection that lets it be HD, but we're working on that. But it's still pretty cool to see the fish coming in the river right now. They are in, yeah. So that is all we have. Any questions or comments?
Have you talked to the folks over at Duluth
The
Aquarium?
Large Lakes? Oh, the aquarium.
Yeah, or is it a Great Lakes Center /
It's a Great Lakes Aquarium. We've talked to the Large Lakes Observatory, which is University of Minnesota Duluth's research facility, and they have a vessel that does education across Lake Superior. So we've been talking with them, but we haven't talked to the aquarium.
Yeah.
Yeah, for the visitor center.
Right.
Mm-hmm.
Because they've been up and running for several years now. And
Yeah.
they probably have a bunch of lessons learned.
Oh, I'm sure. Yeah, that's a good suggestion. Yeah, we haven't gotten to the details yet of what will be in this visitor center, those details, but those are definitely people we want to seek out so we don't repeat those mistakes.
The Olympics, so they come back here this summer, but we've seen them all over.
Yes, we should clarify that map with all the red stars, that was the adults being captured by fishermen. So most of them leave the river after their stock and go wherever. Most of them go to Lake Huron. And then they'll come back to spawn, they come back to the powerhouse.
Yeah.
There is some evidence that natural reproduction occurred, but we haven't seen those naturally produced fish really recur to the fishery, so if we stop stocking, that fishery will just go away.
Yeah, we've found larval fish, but we don't find many adults that aren't marked by us or the state. So one thing that we didn't have time to mention is that we now supply, so the state of Michigan has shifted from stocking a lot of Pacific salmon to Atlantics. They've survived this change in food web a bit better. And we supply all of the eggs for the state of Michigan for their Atlantic salmon rearing. And so, you know, at some point, I mean, if you catch an Atlantic salmon anywhere in the upper Great Lakes, it was, you know, Lake State students that really resulted in
I
that.
caught one about 2 weeks ago, up by, well, around Brogan. That's the second one this year.
You're welcome.
One year, yeah, thank you very much. But 1 year, I don't know what it was, about 4 years ago in front of the casino, there's a lot of structure there. So we fished salmon and, geez, in front of the casino at,
Oh, Bay Mills.
not Bay Mills, Kings Club. The
Oh,
big drop,
Yeah.
so there was, and I think you guys, the same year where you had a study on sturgeon, I remember that.
yeah.
But it was about 4 or 5, and the water was really warm, and there's a lot of depth there. And there was, the Atlantics were there.
Really?
Yeah, it was really nice to see.
Yeah.
Never again, like other than the other, 2 weeks ago.
This year seems to be a good year. I mean, we're getting a lot of
That's
reports
so
of
good to
returns.
see. The Canadians appreciate it. And then, yeah, I heard the other day that someone, not true it is, caught a couple up the Garden River on their side. So it's
Yeah.
good, it's really good.
Yeah, I mean, we were just stocking about 25 to 30,000 a year out of Lake State flats, but now the state dumps an additional 20 to 30
It depends, yeah, on how many.
into the river.
Okay.
So there, you know, we would expect to see more returns. I mean, this year it sounds like the state fish are doing better, but up until this year, the state fish hadn't been returning people weren't catching them as much as they were catching the fish that were directly from Lake State, but that seems to be getting better.
The group that got the basin this past year that were the state fish rods, those are pretty good.
What about Torch Lake? That's an inlet.
Yes.
So you guys planted them there as well?
We do our leftovers.
Yeah?
Yeah, I think those have been, December have been down in the fall, to get down to the density, and I feel like maybe, I'd have to look at the records, but yeah, the DNR, when we give them eggs, they're stocking a number of different points around Lake Huron. I feel like they're stocking.
Oh yeah, we stock, well,
Torch Lake.
the DNR, I don't know if they are intentionally, we stock Torch Lake every year just because we have kind of extras.
Actually, yeah.
So we for many years we've been raising a lot that was on a different temperature, and so they weren't part of our production fish. They were kind of a research
Oh,
group,
I see.
so those often go into Torch Lake. But I don't know if the state is doing a separate stock.
Can't remember which.
But there is, you know, one of the record Atlantics has come out of Torch Lake,
Wow.
and there's a question about, is that our fish? I'm pretty sure it's our fish. We're gonna claim it. Yeah, it's a cool fishery.
Yeah, it is.
With the increased water levels in Superior, does that automatically increase the flow regime over in Little Rapids, or is it complex release flows, or how does that work?
The gates, you know, I mean, it depends on, you know, I only know at a very basic level, but the IJs, the International Joint Commission, evaluates a ratio of the water level in Lake Superior to Lake Huron. And when that ratio is off, they open more compensating gates to bring it back to that ratio. So early in the summer, I can't remember how many gates we had open. It was like a half or one gate, and I'm not sure what they're at now, but it's high. I was going to say 5 or 6.
I think it's 5 right now.
Does that,
It's high.
does that flow through the Little Rapids?
Yes.
Oh, okay. So
So-
you're anticipating maybe additional substrate cleansing,
Yeah.
right?
Yeah, I mean, most of it was cleaned pretty quickly.
Okay.
Yeah, I mean, it looks really good now, but I would anticipate somewhat over time.
What's the depth of the water?
It varies. You know, right now, so we used to be able to boat easily underneath the bridge, and now our motor is like a quarter of an inch, and we're all like doing limbo to get under. So it varies. Right now, I would say At the main part, like where it's really cleaned it out, it's probably closer to 12 feet. And then the edges are, I mean, I can't get out except right on the edge, so maybe 3 or 4. When, at the beginning of the summer, we could almost wade, I mean, I couldn't still wade that deep part. It was probably still 6 or 7 feet. It's a lot deeper than I expected based on the model. It's really beautiful.
But it is very diverse.
It's very
There's
diverse,
shoals
yeah.
that come to the top in some areas.
Yeah.
And in other areas, there's those troughs where you can't really see.
We should take your walleye boat through it.
Yeah, not now. Well, what is the coolest thing, I think, I mean, it's not cool in a good way, but which I've never seen anywhere is how the freighters impact that volume of water. You know, if you've been out fishing on the river or you work in the river, you see it even in the Little Rapids area where all that water's coming through in that depth. We'll put in our drift nets, which you can see the current, and when a freighter comes through the freighter channel, which is way far away, it sucks so much water out that our nets essentially suck in reverse. And then 5 minutes later, it pushes it back in. It is so what's cool is the power of a freighter can move that volume of water. Now, my thought is that has more of an impact on cleaning out substrate than any change in compensating gates, which happens relatively slowly.
Maybe it's just keeping it more suspended
Yeah,
rather than hitting the bottom.
yeah. It is a beautiful area. I highly recommend you check it out if you haven't seen it. Well worth the 8 minutes.
So what's the time frame in this new facility that you're talking about? Do you have a time frame?
Well,
We're hesitant because we've said this before.
I mean, there are deadlines associated with the state funding. There's so much in flux right now, though, because of the siting issue. You know, we're anticipating to be able to do a new build at Alfred Park, but that is not 100%. So it's
Yeah.
still in flux, but I mean,
We have almost 9 million from the state. We have 1 million raised from private funds. We need 2 more million. We have to start spending Lake State's money before we can use the state's money. And so if we find a $2 million donor tomorrow, it's going to be, as soon as we can break ground. But I'm guessing it's going to take us at least a year. We're a little university with a very small alumni base.
Do you have to reestablish the problem with the dock?
We do. That's part of the agreement, is that we would shore up the shoreline, which we actually see as a benefit.
well, the shoreline in front of whatever piece of property we end up receiving, we would have to redevelop. But the dock, the carbide dock, the ownership of that would be maintained by the city. And that's a more expensive project. So,
Yeah, we wouldn't be in that area.
You're going to be back up by the road.
We'll be, we would be where, like the horseshoe pits are,
Okay.
that area, and the parking lot.
Well, where are we gonna play horseshoes?
I was just gonna say that.
Oh, there's a
That could be a problem with people.
Eric, if you
We'll find
make a
you.
donation, if you make a donation, we'll make some more tickets.
Build around it.
I'm waiting for the editorial to come out and see if you news about how we're going to take over their horseshoe pits.
So we kind of got to wrap it up.
Yeah, we're good.
Any other? Is that it? Thank you, everybody.
Thank you. I live on Little Bay to Dock.